the unbounding period could be slashed from 21 days to just a few hours.
To just a few hours?
Yeah, just a few hours.
All right.
Yeah.
I'm here at Cosmoverse, and this is the last day, and I met up with Fisher from Babylon.
Hi.
And I wanted to talk to you because I think what you're building is really cool. It really, as you describe it, kind of makes the best of both worlds between Bitcoin consensus and proof of stake. If you like these videos, please make sure to subscribe and hit the notification bell to get notified when we put out new interviews. Yeah, thanks for doing this. So what's Babylon, and why did you choose to effectively notarize proof of stake consensus in Bitcoin?
Yeah, sure. So arguably, Bitcoin is the most secure blockchain in the world, no matter the proof of work world or the proof of stake world. And on the other hand, POS chains such as Cosmos zones have fast finality, very good energy efficiency, but the security level is not as good as Bitcoin. So that's why we want to bring the best of two worlds by extract the Bitcoin security to the Cosmos zones.
Yeah, I mean, that's super cool because I think, like, as you were explaining to me earlier, it unlocks so much practical applications for proof of stake chains. It's not just like a gimmick of, hey, we're going to timestamp proof of stake blocks in a proof of work blockchain. Yeah, can you talk about, like, why would one want to do this? Why would we want to, put the proof of stake blocks in proof of work?
Yeah, sure, of course. So, I mean, like, bringing Bitcoin security to a Cosmos zone is like very abstract. So yeah, once you have Bitcoin security, so what, right? So I would like to describe to you a very concrete use case once you get Bitcoin security. So I would like to start by asking you a question indeed. Yeah, if you imagine you are a Cosmos zone staker or validator, and you want to get your token back for some reason or part of it, how long does it usually take?
Well, it usually takes between like 14 and 21 days, depending on the chain.
21. I even heard there are projects with 28 days.
Yeah, there are 28 days also,
Yeah, so why so long, right?
I mean, I think it has to do with, potential reorgs, but
Yeah, exactly. So Tendermint provide fast finality, but that finality is only in short term. If we look at a longer time scale, POS or Tendermint is not that secure because once you unbond, take your money back, then you attack the system by reorging or create a fork. The system is not able to slash you because you already cash out.
Yeah.
Right. So in order to prevent you from doing such attacks after you unbound, they set a very long unbounding period, and during this period, they will check whether you have done anything wrong to the system or not.
So this is the nothing at stake problem, or is that a different problem?
Someone call it long-range attacks.
Long-range attacks,
or restake or stake reuse. Yeah.
Okay. Yeah. And so so by having Bitcoin transactions secure a proof of stake chain, you were able to then get security guarantees that the stake that's been unbonded hasn't been used, won't be used for a sort of long-range attack.
Yeah. So to explain this, I would like to first describe what happens within these 21 days.
Yeah.
Currently. Okay. So currently, during these 21 days, the stakeholders of the POS chain or Tendermint or Cosmos zone, they do something called social consensus. It's like they get together through like WhatsApp, Twitter, or Telegram. They say, okay, this week the chain has grown to height 100, and the corresponding block header hash is XYZ. This is finalized. We agreed on this checkpoint.
Wait, what? Yeah. Validators get together in WhatsApp groups to agree on what's finalized?
Yeah. So if you go to the Tendermint client, if you the software, if you want to launch a new node, you find that in the configuration, there's a line asks you, what's the trusted height and the trusted hash? That's anything before that, you believe it is the ground truth.
Okay.
Then how do you get this trusted height?
Okay,
trusted
up
hash?
to a certain height.
Up
okay.
to a,
So
You-
like, yeah.
yeah.
At which height in like the entire history of the Cosmos chain, for instance, do we think like this is the trusted? We all agree that this is like the trusted height. And so what you're saying is that there's a kind of rough consensus that happens off-chain
Yeah.
where people get together in Telegram groups or Discords or whatever to decide that like this is the trusted height, and that is constantly sort of moving forward as the chain grows.
Yeah, exactly.
I didn't know this.
Yeah, so if you read the Tendermint document, it actually says you should grab this height and hash either through a trusted node or through your friends or through a social media, where people now all follow the Twitter of the founder. Yeah. Yeah, so that you can get a trusted height and hash.
That's insane.
Yeah.
Okay. And so like this trusted height, how often does this happen?
Oh, it's actually up to the chain itself.
Yeah, but on average, like over a
I would say,
week or 2 weeks or
yeah. So roughly, I would say every week.
Okay.
So every week they decide on this is the latest trust height and hash. This is the latest trust height and hash.
Okay.
So like human. So this is like a human checkpointing.
Okay.
Right. It takes time. So that's why it has 14 days, 21 days, 28 days.
Okay.
Yeah.
And so all right, so I'm beginning to understand here. So basically by having a checkpoint in Bitcoin, you're able to eliminate that human checkpointing because Bitcoin is essentially, after a certain amount of blocks passed, we have high probabilistic guarantees that is the longest chain and that these transactions have been notarized. Yeah,
notarized, exactly.
So I use the term notarized, but it's like a professional deformation from having done like a previous startup and like notarizing things in Bitcoin, but checkpointing.
You get it. So the human version of the checkpointing I described is called social consensus. And it also has another more academic name called weak subjectivity.
Okay.
It's subjective because it's human making a decision offline, off the chain. So it's subjective. So from this perspective, basically what Babylon does for the zones is to replace this human checkpointing with automatic and 100% objective checkpointing to Bitcoin.
Okay.
Which only, as you said, only take a few hours to notarize, to finalize.
So let's dive into how this is architectured and like what Babylon is as a chain and how it actually like checkpoints the Bitcoin. Yeah.
So asking about from Babylon to Bitcoin.
Yeah, like let's describe the architecture and how the Babylon chain like issues that transactions to Bitcoin, and how is it able to understand also and like parse Bitcoin to know that something's been there in order to have these shorter checkpoint times.
Okay, so indeed our architecture had 3 layers. The trust anchor is Bitcoin. Yeah. And then Babylon chain in the middle as an aggregator of the checkpoints. And then in the 3rd layer is the Cosmos zones. Okay. They send their signed block headers to Babylon as checkpoint. Babylon aggregates all of them and generate succinct checkpoints to Bitcoin.
Okay.
Yeah.
So all of the Cosmos zones, I guess, connect to Babylon via IBC?
Via IBC,
okay,
exactly.
And so they're sending an IBC message to Babylon. Babylon aggregates those like on an epoch scale, or
it's actually simpler than that.
Okay.
IBC already. So with IBC, so what does IBC do? It's actually maintaining at the transport layer of IBC. It maintains the header chain of both the sender chain and the receiver chain. So by opening an IBC connection between a Cosmos zone and Babylon, IBC already upload all the headers of the Cosmos zones.
This is automatic. So no one has to issue a transaction to Babylon. It's just by having a connection, an IBC relay, Babylon already has the information.
You only need occasionally send a dummy message, IBC packet, to Babylon to trigger the synchronization of the header.
Got it. Okay.
Yeah, the message itself can just be hello. Doesn't have to mean anything. Okay. So all the headers of the zone will be inside Babylon ledger. Then Babylon checkpoints itself to Bitcoin, which will ultimately allow the entire header chain of the Cosmos zone to have Bitcoin timestamp.
Okay.
Yeah.
So how does Babylon submit transactions to the Bitcoin network?
Okay, great question. So as we all know,
So just one second. So Babylon is a chain. It has validators.
yeah, it has its own validators.
Okay. All right.
Yeah,
Okay.
yeah, it's a decentralized chain with its own validators. Yes. So as we all know, Bitcoin has a very, very tight space, and it's also very slow. Right. So in order for Babylon to send checkpoints to Bitcoin, we want to make sure our checkpoint data is succinct, very small, and it should be infrequent. We can't just send checkpoints to Bitcoin like every 10 seconds.
Yeah.
Yeah, that doesn't make sense. So Babylon has invented quite a few innovations and techniques to make sure our checkpoint to Bitcoin is secure, succinct, and infrequent.
Okay.
So one of the measures we take is we introduce the concept of epoch. Say every 400 Babylon blocks forms an epoch. And within this epoch, we do not allow Babylon validators to change. That means whatever staking or unbounding request happening within epoch is delayed to the end of the epoch, so that during the epoch, the validator set does not change. Right. In this way, we only need to checkpoint the last block of an epoch, because if this block is checkpointed, it implicitly checkpoints all the decisions made by the same validator set. So it enables slashable security.
Okay.
So this way, roughly, Babylon only needs to send checkpoints to Bitcoin every half an hour.
Every half hour.
Yeah.
So every half hour, Babylon is creating a Bitcoin transaction.
Creating a checkpoint.
A checkpoint.
To be submitted.
Oh, okay. Which is
Bitcoin.
like then Merkleized, perhaps, like probably Merkleized and then
Yeah.
sent to Bitcoin at the end of the epoch.
Yeah, and in order to make the checkpoint verifiable, then the checkpoint needs to be signed by Babylon validators.
Yeah.
If we use ordinary signature algorithms, then like Babylon has 100 validators, then the signatures list will be super long.
Yeah.
Right. Then we adopt the most advanced cryptographic signature algorithm called BLS, signature multi-sig, which allows anyone to sign a message, and the signature can be aggregated into just one signature.
Okay.
Yeah. So the checkpoint is the BLS multi-sig of the last block.
Okay.
Yeah.
So I have a question because I don't think I understand BLS signatures very well. I get threshold signatures, but why BLS and not threshold? Because I think like Axelar uses threshold signatures.
Yeah,
like
and Nomic also use it.
Right. So why BLS and not like threshold?
Okay, great question. So if we want to use use threshold signature, then there needs a ceremony. It's needed before anything can happen. So what's a threshold signature? It means a set of stakeholders, they run a program or ceremony together, and everyone get their own private key, such that if more than a certain percent of the validators in this group sign it, then this signature becomes valid.
Okay.
Yeah. So in order to have this threshold, say 2/3, 20 or 51% or whatever, there needs to be a ceremony among all the validators.
Okay.
Yeah. So we don't want this to happen, because otherwise, whenever there's a validator set change in Babylon, we need to run a ceremony. Yeah.
Okay, I see.
And also, this, in order to use this, the checkpointing has to use BTC's taproot transaction.
Okay.
The Snore multi-sig taproot transaction. So this makes the checkpointing deeply coupled with Bitcoin.
Got it.
If the Bitcoin community changes its mind, say, oh, no, I am not going to support multi-sig someday, then the system will just break down.
Okay.
So we want to use Bitcoin in the most respectful and efficient way.
Bitcoin native way.
Native way, yeah.
Okay.
So we create our signatures using BRS multi-sig, which is not dependent on Bitcoin.
Okay.
So then anyone who sees this checkpoint data can submit it to Bitcoin, use the most simple Bitcoin transaction called op return transaction, which allows carrying arbitrary data.
So for our listeners who maybe are not familiar with this, because I realize like a lot of a lot of people listening are probably, or watching are probably more like Cosmos proof of stake. And so in Bitcoin, in a Bitcoin transaction, we have this field called op return, and it is essentially a field that allows us to put like, I think 80 bytes of data.
Exactly, 80 bytes.
And you can put any data in here, and like there's been lots of companies and projects over the years that have like leveraged this op return field to say notarize like a document. So you've got like a hash of a document and you put it there and you can prove that it exists at one point in time. There were also projects like Colored Coin back in the day, which like pre-Ethereum, that were trying to do like tokens essentially on Bitcoin, and they were using, you're familiar with Colored Coin? Yeah. It's like OG Bitcoin stuff, right? And like before there were ARC20 tokens, there were Colored Coins, and you could create essentially kind of like these tokens that would exist sort of as a secondary layer on top of Bitcoin, but essentially they were leveraging this op return field to parse the transaction data. It was a little cumbersome, but it worked. And like I remember having like counterparty tokens and stuff for different projects back in the day. So like, yeah, so that's the Bitcoin thing. And so this has like high security guarantees. So whatever you put in here, once the Bitcoin chain, once the chain is long enough, like that hash is, has been effectively kind of secured there.
Secured, authorized.
So who's issuing that transaction? Because a blockchain, a proof of stake Cosmos blockchain, as far as I know, can't make Bitcoin transactions, or like they don't have a Bitcoin client.
Yeah, great. This is a great question. I think that's one of the many elegance of a Babylon system. Anyone who sees the checkpoint created within Babylon chain can use their own Bitcoin wallet to submit the checkpoints to Bitcoin. And then Babylon will reward this volunteer by asking them to put a Babylon address inside the checkpoint, so that when Babylon receives that checkpoint back and verifies it, Babylon can provide Babylon tokens as a reward to the voluntary submitter.
So some random person sees these checkpoints, or looking at the Babylon chain, sees these checkpoints, submits that transaction to Bitcoin using his wallet. Maybe there's like some easier way to do this than like copy pasting into a wallet, but like whatever. Like they're basically making a Bitcoin transaction. In that transaction, they're also including an address, and then the chain is able to parse this and then reward that person in tokens. Why wouldn't it be possible to have like all the validators run a Bitcoin-like client and be able to make the transaction? Wouldn't that be possible to do that?
It could be possible. Actually, the validators are motivated to help the system submit checkpoints to Bitcoin, because if no one submits, then according to Babylon's unbounding rule, then no one can unbound.
I mean, at the end of the day, you'll submit, or like someone from the Babylon team will submit, right? But I mean, if the validator, if the client basically could have a Bitcoin-like client and be able to make that transaction. What happens if two people, so what happens if like you make that transaction and then I also make that transaction?
We will split the reward.
Okay, so if like 100 people are making the transaction,
then it will become very thin.
Oh, that's okay. So how do you handle incentives there?
Well, so the designing of the incentive is like in our next stage.
Okay.
We just proved that we can actually send very succinct checkpoints to Bitcoin. So I think that the beauty of this solution is that you only need one honest submitter in the entire world to make the system work. And also, in order to solve the concern you just raised, Babylon also indeed provide APIs for the submitter to check whether this checkpoint has already been submitted or not. If it has already been submitted, don't waste your time.
So the last piece of the puzzle here is to understand how the chains that are submitting block header information to Babylon, how they get to parse this information, because that's the whole point, right? The point is for the chains to parse this information so that effectively we can have shorter unbonding periods on staking periods. So how does that work? Like how do the chains get all this information?
Okay, so there are two steps here. So first, I just mentioned that the Babylon checkpoints will be reported to Babylon with the inclusion proof towards Bitcoin, so that Babylon will use the IBC connection to report the checkpoints back to the Cosmos zone with the inclusion proof of the checkpoint at the Babylon. So this is the first step. That means by simply building a IBC connection with Babylon, the Cosmos zone can already get the BTC timestamps.
Yeah.
Then comes the next step, how to interpret it, the
Yeah.
timestamp. Then Babylon will provide, so if you wish, you want to have Babylon support, then Babylon actually provides you a new Cosmos module that process the checkpoints and compare it with the BTC mainnet and make sure the checkpoint is deep enough. Once it's deep enough, you will send a signal to the staking module of the Cosmos zone. And say, hey, from BTC's perspective, this is good to go.
So there's a new module, a new Cosmos SDK module that Babylon will provide.
Yes.
Chains that want to benefit from this get to just implement that module in a chain upgrade, and then that module sends information to the staking module and assuring it that there has been a Bitcoin checkpoint, and then I guess chains they would all like change their unbonding periods to like 3 days or something, or
So using pseudocode, then currently the unbonding rule is if the unbonding request is 21 days old, or it's like say 10,000 blocks old in terms of the Cosmos zone block, okay, then unbound. Now this line is changed to if 21 days or Bitcoin says okay.
Okay.
Yeah.
Okay. So there need to be an upgrade also to like the chains, like individual chains binaries.
Yes.
Okay.
So I would imagine there will be a governance. To update the software.
Okay. And do chains have to pay anything to Babylon? Like, I mean, does Babylon have a revenue model that chains would pay it to do this?
Yeah. So when the Zoom submit transactions to Babylon, so there will be a transaction. There will be a transaction fee. Yeah. And this
Sorry.
So when the Cosmos zone submit checkpoints to Babylon, then there will be a transaction fee paid.
Okay.
Yeah. So which is ultimately handled by IBC.
Okay.
Yeah. But for now, we focus on bringing the security. So how to do the economic side, we haven't fully figured that out.
Okay.
Yeah.
This is super cool. I really like this. I mean,
thank you so much.
I like it because it makes use of Bitcoin, and I think making use of Bitcoin for things like this is something that I've been very interested in, for a long time. Like using Bitcoin to secure information that isn't transactional, but it's also cool because it has like a practical application, which is that it reduces bonding unstaking periods for Cosmos zones. What's the roadmap? Like, when are you launching, and how can people start learning more about Babylon?
So we are currently at our definite stage. I mean, we have just finished development of the Babylon chain itself and its checkpointing mechanism to Bitcoin.
Yeah.
So our next step is to launch a public testnet with necessary APIs for the Cosmos zones to try out Babylon. So ideally, we will have like a joint testnet, Babylon testnet and the Cosmos zone testnet connected through IBC. Then we can see from the Cosmos zone side, the unbonding period could be slashed from 21 days to just a few hours.
To just a few hours?
Yeah, just a few hours.
All right.
Yeah.
Well, this is cool. Thanks so much. I'm looking forward to learning more about this. And
thank you so much, Sebastian, for giving me a chance to explain Babylon to the world.
Thank you.
Thank you very much, Sebastian.